Hello out there. My name is Bret. This is my channel, and I'm here every Thursday talking about Docker, containers, Kubernetes, all things DevOps in container land. So if you haven't been here before, ask your questions early because we tend to get a lot, and I tend to only stay on for an hour. Some days we're on here 2.5 hours answering questions. So today is not going to be one of those days, so we'll try to keep it to an hour. I've got specific topics I want to talk about, but I don't have a guest today, so I'm welcome to take questions on anything. But what I'm going to be focusing on is talking about an example repo that I'm building for focusing on GitHub Actions, and then specifically today, talking about GitHub, something they built called Super-Linter, which is a linter of linters, or a package of mini linters that makes it really easy to just sort of blanket your repo and everything you might have in it with linting. And then security scanning your images before you send them off to your Docker registry, or wherever you're keeping your images, right? So those are things that I'm trying to add to every one of my projects, and I'm also working on them with various clients of mine that are considering GitHub Actions as an alternative or a future of their continuous integration. And so this is a topic on the top of my head. I'm working on it all the time. So I thought let's talk about it. Let me share some of the things I've learned. I've mentioned it several shows recently. You can actually go back on the Bret.live right there. You can go back and you can see previous episodes where I've talked about GitHub Actions quite a bit this year, especially recently in the last few months. But today I wanted to focus specifically on the linting and the security scanning, because those are two things that linting maybe people do, but security scanning doesn't necessarily come automatically in the CI workflow of people. Like they usually will, if they're going to add some sort of security scanner, it may be code only, it may not be image-based, it may be in their image registry. Like if you use something like Harbor, which is an open source registry for Docker images, that Harbor has an integration where it can run an open source scanner inside it, but that's only when you push the image and then it scans. So what if we shift left, as we like to talk about it, shift left security, where we bring that even closer to the developer by scanning while we're doing a PR, for example, where we're building our software and we can see the results of our dependencies. Maybe we've added NPM dependencies into our app and we want to see those in CI alerting us of potential security risks before it gets into an image registry or potentially on a server in production. So these are all things that I think about and I work on with teams. This is very much a part of the DevOps lifecycle where you are shifting you're wearing many hats and you're shifting your focus. Maybe one day you're focused on images in a registry, getting on a server, but on another day, like today, I'm focused more on CI. And how can I take tooling that maybe not every developer is running locally, and how can I make that consistent on every PR they're doing? So if they create a PR, start running these things right away, and then run it on every commit in that PR, and then once the PR is merged into the specific branch that you're shipping, then that's when things like images ship into your registry, right? That's a very typical modern container workflow, is that we do a bunch of things in CI, but we don't ship that image until certain patterns exist. Like maybe it's a part of an epic, so it ships as an image automatically with a specific name in it. Or maybe we only ship the image up to the registry. We only push it once code is accepted in the main branch or something like that. So I'm happy to talk about any questions like that today. We already had the very first question before the show started from Biker asking around GitHub Actions and GitLab, which is he's considering, as well as Apache Airflow, which is a code-based workflow engine rather than a YAML-based. I have seen some of these before, and there's a couple of immediate thoughts. One, I've never used Airflow. I don't think I've ever actually heard of it, so I'm not going to have a strong opinion on that at all. But I would say that the choice of your the choice of your continuous integration platform is very much from what I see, a culture decision as much as it is a tool decision, because the CI workflow tool is something that it is something that in some teams I see every developer adding YAML, stuff. Maybe if they're using CI platforms like back we had Travis back in the day. There's other ones that are YAML based. I'm trying to think of CodeShip, Circle CI, and maybe some of the Jenkins stuff, but I'll get into Jenkins in a second. A lot of these PaaS-based solutions, maybe even Drone, which is an open source solution and it's YAML based. Actually, is it YAML based? Yeah, it's a .drone file. A lot of these tools allow the developer to easily add modifications to CI in their PR of their code. So if they add new code and they need to run an additional test, they can do that in the same PR, and that's the way you should be doing it. In all the teams I work with, allowing more people to help enhance the CI solution as well as monitor what's happening in CI, the better. What I tend to see in what I will call legacy teams or sort of especially pre-container teams, because if they're not yet doing containers, they tend to have other older processes like CI, is they have a Jenkins solution. And this is not necessarily Jenkins' fault, but this is the way I tend to see it implemented. Jenkins is so complex that they'll end up being one person who's the Jenkins person, or maybe two people if you're lucky. They tend to be the people that write the pipelines and write the scripts and the groovies and all these different things that go into Jenkins. And they become the bottleneck because any new developer that wants to help write some new code doesn't understand the CI. They may not even have access to look at Jenkins. They maybe need an account to see Jenkins, or they might have to be on a specific VPN to see Jenkins. And so and then the Jenkins workflows don't always highlight and show up inside of your GitHub pull requests or your GitLab or whatever. And if they do, usually when you want to click on details, then it takes you to the Jenkins system of which you have to have an account, right? So if you've heard me in this channel lately, I've been talking about GitHub Actions either to supplement or replace a lot of these other CI tools, because if your code, wherever your code lives, if your CI is there too, that's one less bottleneck. That's one less thing that's going to get in the way of developers by telling them basically they are responsible for their own testing and their own linting and all the things of their PR. So if their PR starts to fail because you've added all this stuff, then it's their job to modify these things, not reach out to the CI person and say, I need you to add a new workflow because my jobs are failing in the PR or whatever. And that's what I start to see happening. So what we want to do is we want to enable everyone in the team, whether they're dev or ops or in the DevOps team or SREs or any of these titles, we want to enable them to see everything they can inside of your, let's say GitHub today, just GitHub. Could be GitLab, could be Bitbucket, but GitHub, see everything in the PR, and then including the logs of everything running inside a CI, and then be able to modify it on the fly, change things, and try to fix them inside their PR. So that's what we're going to go through. All that. Let's see if I got any questions yet. What is linting? Linting is basically tools that check various files for best practices. So if it's a code linter, it's going to check based on your team's way of developing. So for example, if it's a JSON, if it's a JavaScript linter, it might look to make sure you don't have semicolons anymore at the ends of your lines because that's grown out of fashion. It's no longer necessary. So that is something like that. You might have a markdown linter that looks at your README files to make sure that they're proper markdown formatting. You might have a Docker file linter, like the more popular Hadoop lint, that will look at your Docker file to make sure you're following all the best practices and that there's no errors in your file. So it's one way of preventing errors before testing starts. I don't tend to run linting before testing. I run it in parallel because a lot of times linting is more about syntax and less about errors. So I tend to design the workflows so that my linting happens in parallel with whatever testing is going on. And some linting failures may not be a stopper for code testing, right? A lot of them won't. So I don't want them to be in the way. I don't want to fail a linter because I edited a README and it won't end up testing my code or testing a Docker build just because I didn't inline correctly in a markdown file. So I don't want that stuff to happen. But let's get into it. Hello, everyone in the chat. Hello there, everyone. Got all the haze. All right, so let me pull this up. By the way, if you're new to this channel is sponsored by Patreon. I have a Patreon membership. You can buy me a coffee every month if you'd like, and then you get access to some special perks. Or you can just follow. So you click that follow button, and then you'll get about a weekly update of new things I'm creating. This week, we're announcing, I think we kind of technically announced this last week, that all of my courses they now support Apple M1 architecture, which is an ARM64 architecture. And then now we're also supporting in 99.9% of everything, I'm supporting Raspberry Pis that are running a 32-bit architecture. So that's ARM v7. So what this means now is that you should be able to take any of my courses on an Apple M1 as well as regular Intel stuff, as well as Raspberry Pis, AWS Graviton. I think Oracle now has ARM instances. Like there's all these ARM things cropping up lately, and I wanted to support them. So that announcement's going to go out this week. If you're in the courses, we should be getting that out pretty soon. And yeah, so anyway, you would hear about that if you were on Patreon. So just click the follow button. That's free to use, the follow, and it's kind of like an email once a week kind of thing. All right, so this is my example repo that we're going to work on. We're going to iterate on today. And I'm going to go through real quick what is already in there because we've covered some of that before. So if you want some of the basics around GitHub Actions, then I did go through some of that a few weeks ago. If you just go to Bret.live over there, and Bret.live, and then scroll back in the videos, you'll find a GitHub Actions talking about Docker, and we go through some of the basics of getting started. But essentially, with GitHub Actions, which is, I would say largely right now, it's really just a continuous integration system. It's a CI system. It replaces a lot of what Jenkins would do or Circle CI, but it's not yet a great deployment mechanism. So there's some great stuff out there, which I have mentioned in a previous video, around the limitations of using GitHub Actions as a way to deploy your software and your servers. So maybe using it for Terraform, or for using it for Kubernetes files to use kube control with manifests and stuff like that. It's not great at that, largely due around the idea of environments, and that you will have multiple environments and that you need to keep things confined to environments and stuff like that. They recently added some features. You can see all these in settings. You can see down here, this is where I'm storing secrets. You'll see that I have 3 secrets today. I have my Docker Hub token for accessing that, and then we're going to talk about security scanning, so I will talk about Snyk, and I put their token in just a few minutes ago. We also now have this thing, environments, which is GitHub starting to integrate some of its deployment stuff or advanced testing stuff into environmental focused actions, right? So that you can now have a staging and a testing, or dev testing 1 and dev testing 2. You can have these different environments, have different secrets and different stuff happen in your actions for that, right? So that's just the beginning. From my understanding, it's not near as advanced as things like Azure pipelines, or maybe really custom stuff that you would write in Jenkins with a bunch of plugins. So it's not there yet. I'm not too terribly worried about that. One, I think that they're investing a ton of time into this, so we were going to continue to see them try to take away all the reasons to use other deployment workflows. I do see a trend where Microsoft is shifting some of the tooling out of Azure specific into GitHub, so I think that that's probably going to happen with some of their DevOps and Azure pipeline stuff, which they've kind of already announced. And the other thing I'm seeing here is that if you're in cloud native, if you're truly doing stuff with containers and Kubernetes, then you probably are interested in GitOps. Now, we've talked about GitOps a lot over the last year and a half on this channel. And GitOps is something where the infrastructure itself looks at Git and self-corrects, rather than always the push model of you running commands in CI that then pushes changes, right? And so the GitOps workflows work well with GitHub Actions, because GitHub Actions will not kick off those workflows. It'll just be Git itself. The webhooks of GitHub will kick off your GitOps workflows. And that's something we've talked about before. You can probably search in my channel for other GitOps videos. But that's not, we're not going to talk about that today. we're going to talk about this stuff. So all I have is a simple repo here. We're going to ignore the license in the Docker file. This is just the boilerplate stuff in order to have something to run. I need a very generic Docker file that we can build and ship. So you'll see here, all I have is I'm using an Alpine image. I'm running a curl command, and by default, if you don't specify something on the end of your Docker run command line, it'll just spit out the curl help or something. So super little, easy Docker file. But all of your GitHub Action stuff will happen inside the .github folder. This directory is not new. You can actually put templates for your pull requests and your issues. You can put other templating GitHub stuff in here. But the first thing I want to talk about is linting, so we can get that out of the way. So how I do linting, and this is not specific to GitHub itself, but GitHub has something called the Super-Linter. And to me, what Super-Linter does is it does a couple things. One is it doesn't require me to be an expert in every linter for every piece of code or text in my app. It automatically pulls in sort of the best of breed linters, and they have a huge list. And these will automatically detect in your repo, if it looks like a C file, it will lint the C file with CPP. If it looks like a Docker file, it will actually use two linters. I am more of a fan of Hadoolint, and we can get into that if someone's interested in the differences between the two. But I find that Docker file lint it needs maintainers. It hasn't been updated in years, and it's got lots of bugs that I continue to find, so I'm not using it anymore. I'm just using Hadoolint. Anyway, so you can see there's lots of linters here for all sorts of things. There's even a linter here that I tend to disable sometimes called JSCP. So JSCP looks at your code or any file you're using really, but mostly code, and it looks for repetitive code blocks or text blocks and will warn you that, hey, you probably should consolidate this because you're copying and pasting in a lot of different places. I do a lot of example apps, so I tend to have lots of examples that have repetitive stuff because it's showing off examples of things. And so this one will trip on me and fail my linting, so I tend to disable that. So we'll talk about that in a minute on how you do that, how you disable those. But back in our repo, you have the concept in GitHub Actions of workflows, and in each workflow you have jobs, and in each job you have actions or steps. So I have a workflow just for linting, and the cool thing is if you go over here, or if you just scroll down, you will find actually that they will give you this boilerplate code, and so I just copy and paste from here, right? This is a workflow. I copy and paste that into my linter.yaml, and all of your workflows go inside of this directory. And it basically fills all this by default. You'll want to specify your branches here if they're not main, if they're not named main. But essentially what I'm saying here is don't lint on every single branch all the time. You might want it to, but I'm only going to lint if it's either a commit on my main branch, which is my shipping branch, or a pull request against that. So for a developer that might be working in their own branch, if you do branch-based development, then I'm not going to start running any of these things until they create their pull request. And I'm much more in the style of the GitHub flow, where you are making a pull request at the beginning of your work so that people can see your work in public. And so I would expect in this type of workflow where you make the pull request when you have a new feature idea, a new change, and you're making that, and then you're committing against that branch, and that PR is getting updated, and this is running every time that you make a commit. All right, so scrolling down, it does two things. It simply checks out the code, and then it runs the linters. So their package is a GitHub action, and every GitHub action is a Docker image. So it's running this action, and then that linter will go through and do several things. It looks at every linter will run. It'll basically look at the code, analyze the different files you have, and then we'll run specific linters. And two things have to happen. One is it has to see files that are related to that linter before it will run that. It doesn't just run them all blindly. It will only run the ones that it sees files that match the pattern. Secondly, it will only by default run those linters if there's changes in that commit. And that's important because you maybe don't want to lint every file on every commit in the entire repo. That would be a lot of work. So they have this little value by default that says validate all code base false. So I'm saying that here so that it only checks the changes in my commit and not every single file in that commit, right? And then I have to specify my default branch just so it knows where that's at. You need to add your GitHub token in there, and this is a standard line that doesn't mean you have to go get a GitHub token. It just automatically pulls this in. This is a convenience feature of GitHub Actions. And this is an example because it's going to run every one of these linters. And so when you first try this, it's going to complain. There's going to be problems with your linter, right? It's going to there's going to be imperfections in something that you did if you've never linted before. So it's in this one, I don't want to use the Docker file linter. I want to use Hadoop lint. Remember me mentioning that there's 2 of those linters for Docker files. So I'm disabling the one I don't want to use. So this is how you would disable linters. Now, if you want to customize linters, you back up a directory, and there is a directory called, oh, I don't see it in here. Okay, so there should be a directory here called linters. And let me see if I can push that. I'm going to copy some code in. Because you're going to need to customize some of these linters. And I'm going to copy in some files. First, we're just going to, in the GitHub directory, let's see, what is it called? I'm going to back up a directory. Docker. I have another one, by the way. There's 2 repos that are going to eventually be examples. One is going to be a mono repo where you have many different apps in the same repo, which requires a little bit different setup. And then this one, which is a single app per repo, it's a more simple example. And then, so yeah, it's linters. And so in here, we need to make a directory called linters. And what you're going to do in that directory is, in the linters directory, you're going to dump for each linter you want to customize its customization file in the format of it. So the cool thing is if you're moving to this and you have linters already, you'd probably already have custom lint files for each one of those linters. And if you're a JavaScript linter, then you're probably going to have that customization file. It's either a default that you use on your computer for everything you do in JavaScript. I keep saying JSON. In JavaScript, but you might have one in the repo. So you can copy those into here or move them into here. And what the Super-Linter does is it moves them, it copies them into the linter in the right place before it runs it. So it now gives you one subdirectory to keep all your linter customizations, and it's in the same format as each one of those linters. So each one of these files will be named differently, will be formatted differently, and they have all those details over in the Super-Linter README. They talk about where to put those files, and some of these linters support a custom location or a custom file name for their linter customization. So you might be able to do that as well. You can actually see if you scroll down. Let's see, Docker file. See, like some of these, you can do the config location with environment variables so that you can change the location of those. So, but I love the fact that I can put all my linter customizations in a single directory hidden under .github, so it's not clogging up the space in my repo root for all the, especially if you have a mono repo, right? It can really get complicated in there. So what we need to do is, I'm going to copy over my examples. Into this directory. Oh. Do I have any files in there? Maybe I don't. All right. So I need actual linter. So I'm going to borrow from one of my other projects, and I think which one I could use. We're going to go over to my shpod. If you've taken my Kubernetes mastery course, I have this tool called shpod or shpod. And I know I have linters in there. All right, now I've got to find them. Going to open up another Visual Studio Code window. By the way, I'm going to look at questions while I'm doing this. Let's see. Oh, that's why, because they're dot files. All right, we're going to copy those. I'm going to have two windows open. Hopefully that's not too confusing. And then it's the under linters. All right, I'm going to copy these in. All right. So I'm not going to use the Docker file linter. I'm going to use the Hadoop lint, so I don't need that linter example. But this is a good one, because I actually have a bunch of rules that I ignore in this one already. So what I'm doing here is I'm adding in for Hadoop lint. Let me zoom in on this. So Hadoop lint. Ooh. Why did my theme change all of a sudden? All right. So what I'm doing here is I've got ignored rules, and these are things that are basically tweaks to this linter that I don't recommend they be your defaults. I'm not recommending this as defaults. So I'm going to put some comments in here that basically say these are things that I have to use for example apps, because a lot of things I do in example apps are not what you should use in production. For example, I don't pin versions a lot of times because I want the example to not be 4 years old, right? So I want them to be evergreen, as a term that we use, is to be modern and supported as long as possible. So I don't want to pin to version specifically, and I'll often make comments like, don't do this, but I'm going to pin to the generic version or no version. So I will disable all those rules, because a lot of these rules will complain, hey, you're not pinning your apt versions, you're not pinning your npm install versions. And so I disable all those rules. There's also some advanced things you can do in Docker files that these rules maybe don't recognize, especially when you're doing multi-stage stuff where you're copying things in with permissions and all that. It sometimes trips up rules. It's basically the rules are bugged and they don't always support every example. So I've got that stuff commented out. But as long as I have this in here, the Super-Linter is going to copy it in and run it on every PR commit. Peter's asking, do you have a linter YAML within your workflow directory? No. Oh, okay, sorry. I'm seeing your comment. Never mind, misread that. Yeah, so you don't have to. So inside of that workflow, this is where all the linting happens. And this right here, again, it's going to be designed so that over on my website, you can see here under Actions that my linting, see where it says lint codebase? So that is the workflow. We get that title. If I zoom out just a little, it'll actually change the interface. So I have two workflows, right? And those workflows are two different files, but it gets the name of the workflow from the very top. So that's the friendly name of the workflow. So that's what I'm seeing in here. And if I just want to look at my linting workflow, I can see that for each one of these commits, it is going to run this linter. I can also see this stuff in the pull request, which is what I love. So I don't have pull request yet. So we're going to create one here specifically for the security stuff, because I've already done the linting as a part of creating this repo. But we're going to add security scanning to my image. So if we look really quick, let me go back to my code editor. If we look really quick, we talked about this weeks ago again in the Docker GitHub Actions video from 2 or 3, maybe 4 weeks ago. We went through this whole file, and this file basically it ignores some things and it runs on specific things, mostly just pull requests and pushes. But we also have this one run on a schedule using a cron schedule so that it runs even when nothing's happening in the repo. And then we do a workflow dispatch, which technically allows us to run it anytime we want by clicking a button. That's a pretty neat way to run it. So that's what this on statement does here, that array. So the job itself is this one long job that runs synchronously, and it sets up QEMU so that I can emulate different platforms. It sets up Docker build X, which is the new build kit type of thing. It sets up the GitHub caching so that my Docker builds are cached for faster building. It logs into Docker Hub. It logs into GitHub container registry, because I now store all my images in both Docker Hub and on GitHub, so that if people no longer want to use GitHub because of if they don't want to use Docker Hub because of the limits, because sometimes you might hit limits on Docker Hub with free accounts, then you can still use GitHub for my images. Then I use Docker metadata action to add labels and tags to my images. And then I use the build and push action, which does the actual building of the image using caching, and it will only push the image to my registries when the pull request is accepted on my main branch. That's what is right here. Basically, push only when it's not a pull request. And then there's a workaround for caching. There's a caching quirk that affects your size of your caches over time and slows things down. So there's a bug fix essentially in there, and that repo talks about it. Those links do. And then I print out the image digest. So just in case I want to see exactly the SHA hash of the image that was made and then pushed to my registries, inside here, I do this at the very end to do that. All right. So we talked about that before, but what I want to do is I want to add a step in here that security scans, and there's two ways we could do this. We could make a workflow that does a security scan on its own, and nothing else is dependent on that workflow. Basically, if it fails security scans, so what? Things are going to still get built and tested. But you could put in a step here that does the security scan after you build the image, and then it scans the image, not the code, but the stuff in the image. So it'll scan packages, right? So most CVE scanning isn't scanning your code. It's not a code scanner. It's scanning dependencies. So npm dependencies, apt dependencies, the from image, right, that you're coming from, stuff like that. So what we're going to do today is we're going to look at two. Back over to my browser. My two favorite security scanners are Snyk, which is a paid product with freemium features, so you can use some of it for free, and then they add on a layer of paid features that are more comprehensive in the realm of security, because they are a security-focused company. And the other one that I'm specifically going to do first is Trivy. Trivy is a free scanner, open source, made by Aqua, that it was sort of my first favorite. I go back and forth between Snyk and Trivy. In fact, I often will use both, because if you've learned anything about security scanning, especially about CVE scanning, is that it can be opinion-based. and that scanners will show you different results based on two things. One, are they capable of scanning all the things? Because they don't all have the same features. They can't all scan every single thing. So in your case, with your code and your repo, you might get different results because one scanner has more capabilities than the other. Secondly, when it comes to the CVE database and scanning for vulnerabilities, these tools all have defaults and settings that they set. And so they may tell you about things that other scanners won't tell you about, not because they can't find it, but because maybe they don't consider a 4-year-old low-risk vulnerability something that they should warn you about, right? And so they have opinions, and that's okay, which is why it's kind of good to always run two. It's kind of like antivirus scanners. Remember antivirus scanners, you can get tools that will run multiple ones. In my life, I can remember back in the email days, there was a email tool that would pull down different engines in the background. So it would pull down multiple antivirus company scanners and run them all concurrently, which was really cool because different ones would detect different things. So that's kind of been my approach to security scanning and stuff like this. Vulnerability detection it's hard to trust just one system. So what we're going to do is we're going to make a new workflow. And I'm just going to pretend, and this is not pretend because I've actually never done this with Trivy in GitHub Actions. So this isn't pretend. I'm going to act as if I have never done this before and I know nothing about it. So this is showing me an example, like a lot of these marketplace actions do. They show me an example of how to use this. And I already can see that there's some things I want to change because I want to use a more modern Ubuntu. I want to probably have this running on 2004 rather than 1804. So this is a little dated. But I'm just going to copy this and make a new one. Now, there's other ways you can do this. In fact, I'm not even sure if I can do in here inside of VS Code. There is an add-on for GitHub Actions, and it allows you to see their status. Well, this is really cool. You don't have to leave your app to look at your CI. So now your CI is in your development tool. So I recommend this GitHub Action here, this extension. But one thing that I may even be possible that I don't know is that when you're in your app, if you go to Actions, you can say new workflow, and then does it allow me to search? It may not allow me to search. And there's Trivia is not probably on this site. So oh, sorry. Get me back on my GUI. So you can do this in code in your local machine, but if you're on the website, they have this workflow where you can click new workflow. You can just click on something that you see here that if you want it, but the one I want is not here. So I'm just going to say, set up a workflow yourself. And it then takes you straight to the editor. And I'm going to use a search here to find the official Aqua Security Trivy repo. And is it letting me, let's see, what does it let me do? Yeah, so it's not letting me copy in the full file. Kind of hope it would let me do that. Anyway, so I'm going to copy this in because this is an action. So this example file here is a way you could build it. So I'm going to take out all of this stuff and just add in their stuff here. So this is, let's see. Well, and of course it didn't comment it. It's tabbed. So let's get that tab fixed. There we go. All right, so in here, I now have their example inside of a new workflow. Now, this is all super generic, and everything's commented out. So it might be, in this case, it might be faster for us to simply take their example, which it has specific stuff in there. And this might be a little bit easier than using all their comments, right? And all their options. So I'm going to copy this instead. We should probably talk about GitHub code scanning at some point, but that's not related to today because we're not really scanning code. We're scanning dependencies with most of these tools. Snyk may have an ability to do code scanning, but we're on Trivy, and Trivy is focused on dependencies as far as I know, unless they've added a new feature. So I'm going to go in here, and I'm going to do it the hard way inside of my code repo. So I'm going to add a new workflow file. I'm just going to call it Trivy. And I will paste that in. So already I can see on push to certain branches. So I need to change a lot of these things, right? Name, I want to make a friendly name for this thing. So I'm going to call it something like that. And then I'm actually going to copy this out of my other linter because this is probably the same thing I want. So I'm going to copy out of my linter and then paste that stuff in here. So this is all about the triggers, right? This on statement is about triggers. When is this thing supposed to run? And then this is going to be not build, but just going to call it scan. Now on this one, everything happens inside of an image that GitHub Actions creates. And so we're checking out, I'm going to go over to my Docker build and push, and I'm going to copy their stuff out. So runs on and steps. I'm going to use that specific checkout action, trying to keep things consistent, right? So go back to my Trivy, and I'm going to do that so that it's running Ubuntu latest, not a hard-coded one, and then the checkout. Ubuntu 18.04 is a little old, so if you were going to pin a version there, to basically this is the thing that all your future steps will all run in. So you could pin to Ubuntu 20.04 or something like that. Now, what this is doing is, interestingly enough, this one is doing a Docker build command to build the image, and then it's going to scan the image. Now, in this case, like Trivy can be used in multiple ways, but in this case, if I was going to do this, then what I probably would do is I would have this scanner go as a part of my other workflow. So it might be something that I use somewhere else. So over here, I might have to put it down here. So what the interesting part here is that I have this build and push step, and I'm doing that all at once. So what I'm going to need to do now is I'm going to have to break apart the build and push steps. I'm going to build, then scan, then push. Ideally, this is a separate workflow, but it seems like their linter example wants to, let me get rid of that, Their linter example wants to use an actual image. My understanding was, sometimes I get these scanners a little confused. So I'm on Trivy. Yeah, I'm on Trivy. So let's see if they have an example for, yeah, so no, see, it's still using a Docker build over here. Using Trivy to scan your Git repo. Okay, so maybe this is more what we want. In repo mode. And this is an interesting effect. I didn't even know I could do this. This allows me to upload my results to the GitHub security tab. That's actually really neat. Private registry, we don't need to do that. Let's see what other, Elastic Container Registry, Google Registry, self-hosted registry. All right, so I think what we want to do here is if we just want to scan the code and not the image itself, then let's go ahead with the example up here that they give for repo mode. I'm going to use, I only need this part right here. This is their specific step. And so I'm going to, in this Trivy file, do that. And then, I don't know why. Okay, it's giving me an error in the coder that it's giving me a code in VS Code. Because if you didn't know, VS Code by default will look up YAML syntax for each file using a service, a standard service. So it already knows how to manage this file, and it's already detecting problems. But it's basically saying that Trivy has not added essentially their spec to their step, so it can't figure out if this is syntax is correct, right? It can't figure that out. So one of the things that you want to do here is, this step is probably the most important, the severity. So you tend to want to, when you're starting your scanning, you tend to want to start only finding the most critical things, because the reality is every app I've ever used has some vulnerability in it that is known inside the CVE database. So that may not even be necessary or relevant. So I'm going to only show critical here, and that's their default. If I change the severity, let's see what options they have for severity. So critical, high, maybe I can start with critical, and then once I'm okay with the results of that, then I can start looking for high, and then once I'm okay with that, I can maybe go whatever others, if they have medium or low. Yeah, medium, low, unknown. Because if you just left this by default and you let it scan everything, like unknown, low, and medium, all of them, you will probably get hundreds of results. And most real-world production apps will have hundreds of vulnerabilities. And there's nothing you can, a lot of times, a lot of them you can't do anything about it because there is no fix. So one of the things you have to learn about these tools is, by the way, I'm over here looking at their documentation. So unknown, low, medium, high. That you kind of, this is an imperfect science. And so you're never going to have all of your apps zero vulnerabilities, zero low vulnerabilities. And the only way I ever really see that happen is when people build, for example, Golang binaries in a container image that are all their own source code, no real dependencies of other Golang libraries, which is rare, other than maybe the official Go standard libraries. And then something like that where it statically compiles a binary that can't be scanned, right? Because this is not a code scanner inside of a compiled binary. This doesn't do that. So if you do that and then you put it in a Scratch image so that technically your Docker image is only shipping your one binary, maybe it's a Golang, maybe it's a C++ binary, and that's the only thing in there because it's statically compiled, so there's no other dependencies, then your security scanners are always going to show green because there's no way for your image to have any vulnerabilities in it other than your own in the binary, but it can't detect those because it can't scan a binary. So in this case, what we're doing is we're scanning the source code, not the built image. So you will get different results based on both, and I recommend eventually once you get super advanced, you do both. So we're going to try this one, all right? So we're going to do this here, and one thing that we want to do is maybe we want to run this locally to see if it's going to work before we even commit it, right? And one thing I could do is I could just run Trivy, the command line. So you could go download Trivy, you could put it on your file system, you could run it against your source code, or we could run this GitHub action locally. And there's something called act. It's not an official GitHub tool. I wish it was. I wish that they would adopt it. But it's a very popular, the only one that I'm aware of, but a very popular tool for running GitHub Actions locally. It's not perfect, but it gets you very close to just being able to do local runs of your CI, which I believe is very important to enable developers to scan things and do things like CI locally before they commit code in case they want to. But if they don't want to, CI will do that for them. but don't make them wait on CI if they want to run it locally, right? Give people options, give them both. So usually you'll have act on your local machine. So if we go back to the repo and we pull up inside this repo, I have the act command line. And what I need to do is act depends on Docker. So I don't have Docker running. I need to start that. And all you do is run the act command line. And it's smart enough to look up, essentially, because it's specific to GitHub Actions, it will look up your actions and try to run them. All right. Let me wait for Docker to start. So if we look at a little bit of the syntax of this command line, there's lots of options. And I don't really get into too much of the customization of act. I run it. If it doesn't work, oh well, I commit my code and wait for CI to finish. But usually I just run it. All right. So now my Docker is actually running. So let's just see what happens. It's going to run those things. I also should have made sure that this file is saved. Okay, yeah. I'm not sure if that was actually fully saved. While we're waiting on that, I don't know if you know, but GitHub Actions also has its own command line tool, but it's not specific to Actions. There's the GitHub command line tool. So I highly recommend you get that. It's just called GH, but it's the official GitHub CLI. And one of the things you can do in GH is you can look at results of actions, workflows, and different stats, right? So there's stuff specific to that command line if you don't want to use like the GitHub Actions built-in features. So essentially all the GH command line is doing is it's talking to GitHub and giving you information about what you can see on GitHub inside your command line in case you're a command line junkie. So, all right, let's see what's happening over here. And the problem is I'm running 3 different ones, so it's going to give me a bunch of logs. So I see, let me let's get a little bit better. So we're looking for, in this case, it's colored in blue. So we're looking for the blue log lines inside of running all of our workflows. I could probably just run that workflow specifically. So we're seeing the security scanner run here. All right. And the disadvantage here is that we're technically building the image twice, I think, is what one of the things we might be doing here. And we don't really want to do that. We go. No, it doesn't. It doesn't show that it's doing a Docker build because it's in file system mode. So hopefully it's not having to build an image. All right, success. So that's all I get back is success. I have very little. So yeah, so it looks like it is running a Docker run because GitHub Actions automatically comes with Docker. So any action can do Docker commands, all right? And that's what this scanner seems to be doing is it's running their Trivy scanner inside of a Docker container, and it's running the Trivy command inside it. You can actually see that it's passing command line values into the image. And it gave me no complaints. And of course, I'm failing on some of my other workflows because I don't have environment variables for secrets and stuff like that. which you could totally do, but we're not going to do today. So one of the things I want to look up real quick is how to run for a specific workflow. Okay, so I can use list workflows, detect. Path to workflow files, yeah. So I don't see where it's letting me just run just one here. Yeah, I don't want to do that again. Do we have any Trivy fans? I'm sorry, we have any Act fans in the chat that might know? I'm looking to run just one workflow, which I don't normally end up doing. It lets me list workflows, but it doesn't let me just use one workflow. Oh well. You know what? Actually, let me try that. Let me try the act -w. Let's see. And then Trivy. Let me see if I do that. Maybe it'll, yeah, there we go. So it's just going to run if I use -w. So it's not detecting anything. What would be interesting to do is if we go inside the Trivy linter and we say critical, high, medium, low, and we try that again. See if we can't get something to pop on my simple example here. It may not actually show results locally. It may only upload those or put them in a file. Yeah, success. So, and now it's giving me an error. Oh, it can't upload results because it's not running in GitHub. So this is another example of like Act being limited. So it's trying to upload results. So let's go ahead and upload this, and we're just going to see what happens. I'm going to commit this code, and we're basically adding Trivy, and we're adding the ignored stuff. All right. And then I did this in the main. So instead of doing a PR, which I should have done in a PR, we're just going to do a push. And what we will do is we will see that happen over, where's our dashboard? Oh, up here. All right, so in my example repo, I'm going to go over to Actions, and we should see stuff running. Get the little circles. Yellow means it's currently active or queued. You can see over on the right whether it's queued or not. So it looks like I'm running over here. The linter is queued, but this scan is running and has finished. So it doesn't show me the results in line. Maybe that's because I chose to upload the results. So maybe that's why it's not dumping out the results. So if I go over here, let's see what, I probably don't, there we go. There we go. And nothing. Hard to believe. I am using Alpine Edge, so maybe there truly is no dependency vulnerabilities in that image. If we went over, and here's a good example of what would happen if you did something like, let's go into my Docker file, and let's see if I do a really old Ubuntu image, right? I don't think 16.04 is getting security updates anymore. So if I do that, again, we're going to try to run it locally, see what happens, see if it pops any results. Gabriel asked, do you know if there are any differences between ECR image scanning and Trivy? I do not know. I don't know what ECR uses by default. So a quick Google might tell us ECR image. Let's look at the user guide. Okay, so they're using Claire. Claire is another option. It's very, very popular. I tend to like Trivy over Claire. My reasons are possibly out of date because years ago, Claire was not supporting Alpine images nearly as well as it should. And Trivy was. Trivy was properly supporting Alpine images and properly finding vulnerabilities. And so I don't know the status of Claire. It probably supports Alpine now in a much better way, as Alpine has gotten more popular as a Docker image. So so I would just look into that. That's one of those things where the two things that will determine your results on image scanning or any code scanner is what can it detect? And in the case of Claire, years ago, like every other scanner other than Trivy, they were all ignoring Alpine dependencies. So any APK installed dependencies in the Alpine images weren't getting scanned for. So if you installed a really vulnerable version of OpenSSL or something, it wasn't alerting on that in Alpine because it didn't know how to read the packaging formats. And Trivy was one of the first to come up with a solution for how to do that. That was a few years ago. I'm not sure how well that's changed and how well everyone else is caught up. Anyway, so yeah, it looks like Claire over there. And like Harbor can use, I think, multiple ones. They might be able to use Claire and Trivy. I just know that I've seen Harbor, which is an open source container registry. I've seen it used with Trivy, and I believe also with Claire. All right, so what we're going to do is we're just going to commit this code and see if we get any different result. All right, let's go back over to our actions. Oops, over here. Back to our actions. Since we're only focused on Trivy, so we're going to wait on that one. All right. I'm glad you find this interesting, and you are welcome, Gabriel. All right, so this scan is finished. Took 19 seconds. Let's see. It's uploaded its stuff. Let's go over to the security tab, security code scanning, and it's weird. So one of the things is that because I'm integrating this with code scanning, which is GitHub, a specific GitHub feature. Sorry, I need to be over in my browser tab. A specific feature inside of GitHub, code scanning. It may not be working as I expect because I don't have code scanning set up yet. If you just look up GitHub code scanning, so there's a specific feature. It's like about a year ago. So this is a GitHub action, and they have their own, like CodeQL is their own thing. So you can look at the CodeQL website. And I would assume what's supposed to be happening here, because I've not used Trivy in GitHub yet, like this with GitHub Actions. Normally I'm using Trivy locally or in some other CI solution. So what I would expect is that it's going to flag those problems here. So instead of it just being stuff inside of my logs, inside of my CI runs and the workflows, it's actually putting it in the code scanning alerts over here. It's definitely picking it up and showing that this thing is running, but you know, I don't have other tools. Now you can see a lot of these other tools are already here, like Snyk. Yeah, so they've got the Trivy here. So we're gonna go ahead while we're waiting on trying to figure out Trivy. Let's go ahead and do a Snyk workflow. And okay, we'll keep that default name, Snyk container analysis. That's fine. And it automatically pulls in the cron and the push and pull, which is pretty cool in their example. We're running on Ubuntu latest, which if you remember, that's what I wanted to use. And again, their tool is defaulting to building the image and then running the scanner. So what an interesting part about all this workflow is if the scanner is focused on scanning images, which is something that I recommend you do, then you have to build the image. Now, in real world apps, building images often will take minutes, like 5, 10, 15 minutes to build the whole image. So we already do that in a different workflow. And when you start to learn around what GitHub Actions does is when you start a workflow, it's probably in a different VM running in the cloud than a different other workflow. So if you want to take advantage of build caches where you're only building the image once and then you're doing stuff and then when all that passes, then you push the image, what you're probably going to need to do is put it all in the same workflow. So I was talking about that earlier, and we might as well just do that now because it seems like that's what these tools want me to do or prefer that I do. I also like scanning the images because the scanners, in addition to scanning your code dependencies, also look at the OS dependencies, and in images they can do that. They can't really easily do that inside of a code repo because there isn't really a standard for installing apt dependencies in a code repo, right? We do that in a Docker file, but often apps might use a make file. They might have a shell script that installs apt stuff. It might just be stuff in the README. So these code scanners, if they're just scanning a file system repo, they don't get the advantage of OS dependencies, which a lot of apps have, right? PHP apps or Ruby apps. These are all types of apps that need OS dependencies, and we want those scanned too. So you're going to get better long-term results by scanning images, not file systems. But it's cool that at least Trivy has that option, right? That I can do this thing here, and I don't have to build an image to do it. So we're going to leave the Trivy aside. We got our Docker file set up. So what we're going to do is we're now going to go back to our Docker build and push, and we are going to, what we can do is we're just going to add steps. Now, there's an alternative way to do this where we create multiple jobs in this workflow and the jobs depend on each other. But again, you have to make sure that you're taking advantage of caching. And so Docker image caching can be a problem when you try to do things in parallel or do things on multiple machines. So one of the negative attributes of doing it this way is that you're ending up with this long process here is building an image, and if you're going to do other stuff with that image, you're going to have to make sure it's in the same VM running all together because that's where the image is cached. So as you get more advanced, you will graduate from this workflow that I'm about to build to one where you build the image, you then ship it to a temporary registry. Maybe you use GitHub Container Registry temporarily, and you ship it with a temporary name, and then your other jobs or other workflows that you depend on, because you can make dependency trees of all this, those will then pull that image and do the things with that image. That will allow you to do many things in parallel. Like you can lint stuff in the image. You can test the image. You can security scan the image. You can do functional testing and while you're also doing unit testing in a different way. And you can do all this in parallel. And the way that you have to get that workflow to work is to store the image, this artifact that you're going to use. You have to store it somewhere temporarily. And that usually is a temporary registry. Maybe it's a place that you have the registry set up to destroy the image after a few days of not being used, or maybe you're using a specific naming format so that everyone knows to never use that image format, but you need some cleanup. So you might actually have these things that once they're all done, you use a tool that will go delete that image and that specific tag of that image to clean up after yourself. But it has to go to the registry now to do that. What I'm doing here is not that advanced workflow yet. This is simply me building it on a server, and it will stay in the Docker image cache on that server until this job is done. And then once this job is done, it's deleted. That's the default. That's how it works by default. So in order for us to do what we need to do, this little part has to be broken up into two parts. Right now, this is build and push. What I need to do is build, then scan, and if all that's successful, then push, okay? And the way we do that is you can just copy and paste it. So I'm going to copy this out and paste another one right below it for pushing. And then we're going to put stuff between these two. So all of our image scanning is going to go between them. And so I'll just create some space there. And I need to format my YAML. And so on the first one, I'm never going to push, right? It's always going to be false because we don't want to push the image. We just want to keep it here for us to now scan it. So I'm doing all this here. You can see that we're actually going to be doing this on 3 different platforms. So technically, separate video, go back in my YouTube timeline. The separate platforms will all be built in parallel. Each one will be built in its own tree. So this is actually going to happen 3 times. And it's going to stay in the build cache. Now the problem, I'm just realizing, the problem here is because I'm doing 3 platform builds, I need to pick one that's going to be scanned because I'm technically building 3 images here for 3 different platforms. I don't need, since they're in theory, these are all going to be the same code and all the same dependencies, I don't need to scan all 3 probably. We could argue about that. We could debate. But so what I need to do is I need to add a new feature to this Docker build that is going to take a specific platform image and then export it out to Docker so that when I do Docker run commands later for these image scanners, it will use that image. All right. And I don't know the way to do that off the top of my head. I know that it exists. So we're going to go back to the GitHub Docker build and push action. So this is the one that I'm using. And there's a bunch of options. Let's see what we've got. Customizing outputs. No. Load. All right, here we go. Load, I believe, is what I want to use. Ooh, Martin, I'm just now seeing your comment. Sorry, that was a few minutes ago. The FS parameter is the problem. I'll check into that. Thank you for the tip. Yusuf asks, can you do a stream on Copilot and your thoughts? Saw tweets on how much change it brings, especially to writing YAML and manifest. So I technically have, I just got approved for Copilot yesterday. So what'll be interesting to see is how well I have not even had the chance to use it yet. I just enabled it yesterday. I don't know why it keeps changing my theme. So I'll have to check that out. And yes, if I see anything cool with, I'm not really gonna do a stream on development, but if we're talking about some of these CI tools in YAML and manifest and stuff like that, I'm all about that. That's a great idea. Thanks, Yusef. So what I need to do here, getting back to this example, is I think I need to load. Load is a shorthand for output type Docker. Let's see, so load. No, I don't think that's it. All right, so yeah, this is explaining what my problem is going to be. Is that if you do a standard Docker build command, what's actually happening is that the image cache is building it and then loading it into the Docker images cache so that you see it in the list. But when you use buildx like we're doing, it doesn't automatically do that. At least it doesn't do that locally. So what I need to do is figure out how to tell it to load the image into the image cache after it's being built. And type Docker. So the local export type writes all results to a directory in the client. Tar. What I want is Docker. Oh no, that's what we want is the image. We want the image. It will also appear in Docker images. Name, Boolean, automatically push the image. So name references for the new image. So not sure about the format of this. So what we might need to do is load true back here and my load true. So it seems to like that. And so what I think I'm going to do is on this initial one, I'm not going to build all three. Since I'm not going to test all three, I'm not going to build all three. I'm only going to build the AMD 64. And then when we push, I'll build all three. All right. Because this is about security scanning. So we got to also change the name here. So Docker build for scanning. And, or I could just call it Docker build. And then this is just Docker build. And then down here, really Docker build and push. So I'm going to change the ID here. Docker build and push. And down here at the bottom, I also have to change this because this is dependent upon that. Okay, so what I've done now is this is the original one. It's going to stay the same. And then the Docker build is just building so we can scan. So I'm only building the standard AMD Intel compatible. This is a little cache workaround thing that I need to do so that we are sticking with the cache. Yeah. And then, yeah, that's going to create a problem with the cache. I have to figure out how to do that later. Yep. Not everything everything may not be cached there if I do it that way. So, yeah. All right. So anyway, load true means hopefully that any future Docker build command will have that image, so we won't have to rebuild it. And now I'm going to add in. Let's do Snyk, since we were working on Snyk. And yeah, so their action is right here. So line 27, right there. So that's two different steps. It's first scanning it, and it's using my token, which I've already stored. I've already gone and logged into my Snyk account, got my token. I have a free account. I'm not paying for this. So I'm sure it has very limited scanning, or it will complain when I hit my limits or whatever. And then back over here, I'm going to paste that in. And then I'm going to change the formatting just so it could be consistent. All right, so now we're getting somewhere. All right, so now we have this action. So we're using their action. We have their token, and then your image to test. So what I can do here is, I know up here, this is the name I called the image. This is where I define my image name, because I'm using the Docker metadata action. So now I need to tell it the name of that image to scan. All right. Image is not allowed. All right, so this may work. Let's actually run it locally and see how far it gets. So we're going to do the Docker build and push. And I probably messed something up that's going to complain, but let's see how far we get. Any questions so far? Anyone still hanging out with me? We're about an hour and a half in. I thought I was going to get this done in an hour, but it's taking a little longer. Now this may complain. Yep. Yeah, this is going to automatically fail because I don't have my local stuff. So we're just going to have to commit this code, because I'm not going to bother putting all my keys in local environment variables just so that I can log into things. So this time let's actually make it a PR. So I'm going to, let's see, source control. I'm going to call this add Snyk scan, and then we're going to push and then I'm now going to create a pull request. And I can do that if you have the GitHub add-on. You can do pull requests inside of Visual Studio Code. So I have two add-ons that are GitHub related. I have the GitHub add-on extension and then the GitHub Actions extension. So what I'm saying here is I want to take changes from the add Snyk scan into main, And we're going to add sneak scan. All right, so that was a pretty nice workflow that actually took me out a little bit of having to use Git command line. So we're getting to the point now with VS Code that if you understand the Git workflow enough, you can just completely avoid the Git command line and do your commits and your pushes and your PRs and all that just from the GUI. I've been trying to do that this year. I'm a command line person, so I've been trying to force myself to learn the UI and what it can do. It's still not intuitive. I still struggle with that. All right, so if you go back over to our repo and go to pull requests, we should see my new pull request. That little orange dot that you see over here, or yellow dot, is telling me that it's currently doing GitHub Actions on that pull request. And I can now go in the pull request and see each one of my jobs running. And we can see I'm linting. Trivy is doing its thing in its own workflow. Remember, we had a workflow for Trivy. And then now we're putting the Snyk one inside of this workflow. So if I dig in here, we can see that it's almost done. Yeah, it's cleaning up. And all right, so down here, so we did a Docker build. What I love about this too is that I'm putting it all in YAML, which turns into Docker commands, and I can see the command that it's telling me that I'm running. So sometimes when I don't have the YAML formatted correctly, I have to troubleshoot, and I can see the actual Docker command, which makes more sense to me than the YAML formatting. So I can see that it's doing some things with caching. It's adding in a bunch of labels. That's my Docker meta action, adding in a bunch of labels. And then it does its thing. This is the build kit showing me that it's built it. And it says, okay, it's importing to Docker. And then over here, it's running, we're doing a Docker run of the Snyk image with all the options that it sets up. And inside there, it's actually, you can see that it's actually controlling Docker so that the Snyk can do something else with Docker. And let's see, where's it saying? Test Docker file. It also, with Snyk, this is a specific feature of Snyk. If you tell Snyk, hey, look at this image, but also use this Docker file as the basis for how that image was built, it gets smarter. So it knows the from image, and it doesn't have to sort of reverse engineer the history command and try to figure out what your image came from. It can actually just look at the Docker file and how that was used. So it gives it a little bit more intelligence. So now here's the cool thing. It is dumping results right here in my log, which I like. I want this in the log, as well as if we go up to security and we go down to code scanning alerts, let's see what we have here. So nothing. We can see results 365 alerts, but it's not throwing in those alerts here. So 365, crazy. Like, that's a lot. And that's largely due to, my choice of using the Ubuntu old image 1604, right? It's not, because I didn't add any source code in that Docker file. So if I want to get this down, let's see what happens if in this same PR, I'm going to add another commit to this PR and push it. And what I'm going to do is I'm going to go back into the Docker file, and I'm going to change it back to Alpine Edge, which is like the latest, freshest Alpine. All right, and then I'm going to commit that. And I'm going to push that. And then what I should see is the pull request, again, is going to run through Run through changes. All right, here we go. So it's running again. And so I can go and wait inside the details for this. And we'll see it scan again. And what I expect to happen is that a list of vulnerabilities, 300 and whatever we had, is going to be very small to almost nothing, because Alpine is one of the smallest images you can get. Not everything works great in Alpine. I'm actually not a huge fan of Alpine in production for custom code, because a lot of things, I've seen issues with Python, I've seen issues with Node that are specific to Alpine images because of the way that Alpine uses its compilers and because of the way that it's built using a smaller little image that it's based on. So it doesn't always work. So I don't always do Alpine in production. Some people swear by it and say that you got to use it, but I've had, I don't know, a dozen major issues over the years, maybe the last 4 or 5 years with using Alpine, that some of them have actually caused production failures because we chose Alpine as our base image. So you got to really know what you're doing. I would prefer, by default, when people are starting with containers, that they just start with the official images that are Debian based and stick with those until they get smart enough to try Alpine with more education, understanding how Alpine works, what the real differences are in Alpine, and why it's so different to use in a container than something like Debian or Ubuntu or CentOS. And that takes skills, time, takes lots of time there. All right, so let's go to our security over here and see what we got. Go to our code scanning, and we're down from 330 to 39. All right, so this will take me back, and I then have to find the Snyk log. And what the advantage of using something like Snyk does is you can have this stuff, I believe, not a Snyk expert, but I know one, and sometimes he's hanging out in chat, to get this information showing up in their Snyk portal, because you can use their dashboard. And so that might be a paid feature, I'm not really sure, but that's an advantage of using one of these more enterprise-y paid products versus an open source scanner, is that instead of staring at these logs and looking for all the vulnerabilities, so as you can see, like, this is a medium vulnerability, this one's a high vulnerability, and instead of staring at these logs and dealing with them one by one, wouldn't it be nice if I had a place that I could see each one of them listed and I could find more information? It's nice that they at least put the links to their knowledge database on for each one of these results, but the only workflow I would have to deal with this issue now is I'd have to look at each one of these, go and try to address it in my source code or in my Docker file or whatever, and then re-upload this and see the results, and then look through the log again to see if that one's there, right? Like it would be a very tedious workflow. But the dashboard, if you've ever, this is a free account, again, you can poke around their dashboard. It's looking at my GitHub repos, and these are all got tons, because this is stuff that I don't it's all example repos that I don't always well maintain. So it's going to run me through each one of the vulnerabilities and allows me to filter them and do all sorts of things. That's way better than looking at a log, So check that out. And I think that's it. So at this point, it works. Things complete. And it's not failing. If you actually look at continue on continue on error is true inside of this image. So, inside this action. So the last thing I'll point out here is that once you get mature in your security posture, you will want to turn this to false, so that, let's say I only have it looking for critical vulnerabilities, critical and high. And I will turn this to false, which means that it will break my builds. It will prevent pushing the image if there is a high or critical vulnerability. that requires a lot of work on your part because, like, again, this is a simple Docker file that's 3 lines, and I have 39 vulnerabilities. So I have to go address those, understand what they are. Can I even fix them? Do I need to ignore them? And then I have to work through that process of fixing those things. And I may not want my source code to get hung up in that delay. Like maybe I'm just now implementing security scanning. So often when you start, this is a great default, is I just want to be notified of problems with images scanning, but I don't want to fail my builds or prevent me from publishing code or merging my PR or any of those things. And then once you get a really established process for dealing with these, and once you've addressed all the existing ones, then you can turn this to false, and it will break your builds, right? This would only allow me to push images, which is a step lower, where I push images. It would only allow me to push them once it succeeded in passing whatever stuff I've set up here. So I think the next thing I'd want to do is, just like with Trivy, the next thing I'd want is to change the defaults so that it's only looking for maybe critical and high. And maybe we look for level. I'm not seeing that in their documentation on this README. So I'm sure there's customization here that allows me to filter. Let's see, settings page. Yeah. Create an account. Yeah, it talks about the continue on error. So yeah, I'd have to, I guess, look up in their documentation further to see what how that's going to be. Surely they have that. Surely. Somewhere. All right. Well, anyway, I don't see any questions in here. Let's see. Actually, I do. Maybe I do. Biker, is there a way to use GitHub Actions with a private code repo? We host our own Bitbucket server, but may move to Azure repos or GitHub or GitLab. GitHub Actions, as far as I know, only work on GitHub repos. It works on private or public GitHub repos. I don't believe you can run GitHub Actions on non-GitHub repos. I've never seen a way, but because in theory, I guess in theory it's possible. I could be totally wrong about this now that I think about it, because these are all kicked off. One is GitHub Actions is repo based, so you would have to have a repo for the actions. Secondly, it's normally done on a pull and push and commit action, like that's how it's triggered. And so if your code is getting pull requested and committed and all that stuff in another place, then what you're going to have to use is GitHub webhooks. And the way that you use those are with you saw me do this earlier, the dispatch. So there's the workflow dispatch, and there may be more information in there on how to use the webhooks. The problem, though, is that I would get into there is I would say this is breaking a lot of the reasons of why you use GitHub Actions, because GitHub Actions is very similar to a lot of other modern CIs. But if my CI is in one location and my code and all my issues and all the things that I'm doing are in another location, that already will already create problems of friction and functionality. And so if you're on GitLab, use theirs, right? Use their CI. If you're on Bitbucket, I don't even know. Does Bitbucket have a CI? I don't actually even know. So I would probably look at built-in options of whatever tooling I have instead of trying to use GitHub Actions. I don't think at the end of the day, GitHub Actions would be near as good if you were able to put together a solution for it to work on some other product. But that's just me. I haven't tried it, so that's just an impulse. But great question. If you change the branch in that screen, you should be able to see the alerts. Oh, are you talking about in the code scanning alerts. No. Yeah, I'm not. That's not. That's what you're talking about. Who? Or sorry, that was Peter. Peter was suggesting. I don't. If that's what you're talking about, is in the code scanning. I don't see anything on that either. I don't know why it's not showing those. Who? I'm not sure what you're asking. When you click login, nothing happens on GitHub. I'm not sure I can help with that. Peter says Bitbucket has a product called Bamboo. Okay. Yeah, I did that, Peter. I changed the branch. Changed the branch down here, and it's still not showing anything. That's what you're talking about. Because by default, the filter is on all branches, I believe. So it's not filtering to just the main branch. All right. I'm going to, Peter, in case you get more information. Oh, I'm scrolling down. Sorry, I didn't see the comments. Oh, you're talking about VS Code. Who's talking about VS Code? Yeah. Sometimes you do have to restart after extensions. Yeah. So I tried that. Didn't work. Yeah. I might reach out to Snyk and ask him about that. So it also might be intentional. I don't know. Where maybe, I mean, it didn't work for Aqua either. So neither one of the tools have that ability. Can you imagine though? Wait, now that I'm thinking about it, can you imagine creating 39 issues automatically? Yeah, so maybe there's a switch, or maybe I have to do something else, or maybe it's just not something that is recommended because it would create a whole bunch of issues here that I would have to deal with. It is cool. So yeah, okay, so there we go. Yeah, each tool showing 0 alerts. Oh, look at that. Rules. So, wow. So there's lots of rules, but it's not creating an alert. It's just showing. That's interesting. Anyway, I don't have a lot of experience with the code scanning interface, so I will spend more time in that. Because I've never used code QI with a project, so I'm scared of what it'll say about my code, because I'm not the world's best. Oh, okay. Thanks, Peter. Yeah. Got it. All right. Well, so this is me wrapping up, because we've talked about linting, we've talked about security scanning, we've got something here, and we need to build on that. So maybe my next steps will probably be to read more documentation on the security scanners and the functionality. How in the Snyk one can I only show high and critical? That's something I want to figure out. Can I get those results in here? Can I have these in the actions running as, like, some of it scanning before in parallel? One of the problems I'm having here is that in my main action, my main workflow, it's all linear, and there's a lot of steps there. So it turns into, let's see, the build and push. Well, it only took, for this example, it only took 47 seconds to build. But most real world projects, you're constantly trying to speed up your builds. And so anytime you can parallelize tasks, and so ideally, in my jobs, I don't have, if I'm going to use multiple scanners, that they're, if I have to build a Docker image, fine, but I don't want the scanners, I want the scanners running in parallel. I want to minimize the delay, right? So that'll be an exercise in figuring out what things can I run in other workflows, what things can I run that have to depend on an image, and so on. So anyway, I'll be playing with that. Next week, guest, special friend Nirmal Mehta is going to be here next week. So Docker Captain Nirmal will be on the show. We will be talking about DevOps things in general. I don't think we have specific topics, but he is a professional DevOps consultant, and we will talk about DevOps jobs and all things like that. So join us next week at the same time. We'll be focusing on that, and I will see you same time, same place next week here on YouTube Live. Ciao, everyone. Thanks for joining. See you soon.